Hi there. So today we're going to be working on using BLAST. I notice a lot of times with the BLAST program, a lot of students are not necessarily familiar or comfortable using the BLAST resource. I tell people to kind of think about BLAST as a Google for genetics, genomes, because it's really helpful. It's a really great resource to use, especially as you go further past just your basic intro genetics class and you're looking at evolutionary theories and virology and all different types of things where you're going to have to use genetics and compare genomes. So today let's start with the basics and the one that's pertinent to this lab that we're doing right now, the D-loop lab that we're doing in this course. Um, and we're going to be using the nucleotide blast. So as you can tell, when you go to the blast website, there's all different types of blasts which you can perform. The blast being, I guess you take a sequence that's given to you. In this case, would be a nucleotide sequence that's given or a nucleotide sequence that's found. And from there, you can find the nucleotides, that would be the nucleotide blast, or you can take a translated nucleotide, which you found via nucleotide blast, and find the functional protein. So there's all different types of blasts which you can perform, but today we're going to be focusing on the nucleotide blast, nucleotide to nucleotide. Is that enough nucleotides for you? But all right, yes, let's move on. Okay, so here we're given the chance to enter a Curie sequence. So I have a sample, and I'm just going to copy paste that here. This is a given sample, just an example for today. You also have the option of uploading a file. So if you're given a file with the sequence, that's also really helpful too in terms of accuracy. It takes a little longer to upload it, but it's really helpful. Some other options that you have when you're performing a blast is you can specify what organisms you're looking for, and you can also look for highly similar sequences versus more dissimilar sequences, somewhat similar sequences. So there's a lot of things that you can do in terms of specification when it comes to a blast. In this case, I'm going to be performing a simple blast. I don't know what the organism is. I don't know what I want for any of this. I kind of just want to see if I can identify what it is. So I'm going to press blast and I have show results in a new window. And it's searching. Okay, perfect. So after I've entered my nucleotide and blast it, I have this come up, and these are plenty of sequences, 100 different sequences, and these are all the sequences that have matches with that exact sequence. So there's 100 of them, and as you can see here, the major thing that I look for is I look at their percent identities. So if I'm looking to identify something, I'm going to look at something with the highest percent identity. So in order to do that, I'm going to look at this top one, 99.21%, and by clicking on that, I can look at the query sequence and the subject sequence, and we can see that it's an isolate from Homo sapiens, so it's human. And you can click on the sequence ID to learn more about this. If I were to keep scrolling, that would just be those same sequences that were in those 100 sequences listed right there. So just for the sake of demonstration, let's click on this sequence ID, EU720294.1. Oh, also right before I do that, we can see that they list length. So a lot of these have similar lengths. They also have similar percent identities. And if I wanted to have a different view, so this is, we're looking at pairwise alignment. If I wanted to have the pairwise alignment with dots for identities and specific identities listed there in red, then I could do that as well. And as you can tell, these have very similar percent identities, and that is congruent with what's portrayed here. So hopefully that's helpful for anyone who didn't. A lot of students actually didn't know how to do this. So definitely take a look at this if you're not yet fully familiar with the BLAST website. So let me just go back here and click on the sequence ID. If I could just click on it. Oh, all right. So here we have more information on the sequence ID. So we have plenty of info here. Tells you what organism it's from. So if it was from a mouse, it would say, mouse, or I mean, it would say the taxonomic name for it at least. And like I said before, this is essentially like Google, but for genetics and genomes. So the way that they actually get this information is through entries, I guess like article type of entries. So you can see exactly like the articles that actually this genome sequence, this genetic sequence came from. And that is here, it's linked here. And as you can see, this is from an article called Validating the Farming Language Dispersal Hypothesis with Genetic Variation Exhibited by Populations in the Southwest and Mesoamerica. So if I wanted to gain more information about this sequence, about its origin, then I could read this article, and just looking at the sequence, and just looking at the article linked with the sequence, we can see that this is sourced from some sort of indigenous population from the American Southwest and Mesoamerica. And if I wanted to, I can go to some figures there. And oh, this is great. We have some information about the haplogroup and the different haplotypes. So if I wanted to read more about that, I could do that there. And that's actually very helpful in some of the labs that will be assigned to you throughout this genetics course. So definitely, definitely make sure you're comfortable using BLAST to figure out haplotypes and things like that. Let me go back here. Go back to sequence ID. I just want to show you guys another thing that you can do. Oh, we're back here. Okay, so this is actually really awesome because you can search a nucleotide and then you can get some information on the translation, so you can figure out more information about the proteins and things that they code for. And yeah, it's just really, really useful, really, really fun if you play around with it, if you find some really interesting genome sequences. And let's go back here because I also would like to show you guys how to use BLAST to get a graphic summary of these alignments. And let's deselect. So say I wanted to compare 4 or 5 sequences. So I'm going to deselect the 100 and I'm going to select the 4 or 5 sequences that I would like to look at. Now in this case, because they're percentage identities, there's not a very much of a difference. The differences are negligible. We're not going to see a vast difference in terms of the graphic portrayal of them. However, this is really interesting if you do have you are blasting something where there are vast differences, then you can get this really cool graphic here. And as you can see, it's color coded. So if there's high alignment score, so alignment scores that are over 200, then you'll have them all red, which is what we have here, which makes sense because their percent identities are all over 98%. However, if you were comparing things with more of a difference, then you would see, black bars, blue bars, green bars, pink bars. And those are just really cool to compare them. So let's go back to our descriptions and we'll select all of them just because I want to show you guys also how to do a distance tree of results. This is also really helpful for anytime you have to do a lab report, especially where you wanted to show, I guess, a phylogenetic tree or a taxonomic tree, you can actually do that. So the way I got here was I clicked distance tree results, and you can choose between 2 different methods, which would be fast minimum evolution and neighbor joining. I enjoy using fast minimum evolution, and you can actually specify if there's a degree or a maximum of sequence differences that you would like for those portrayed. So we'll keep it here at 0.75. And then, oh, this is really good. This is really useful. You can also decide whether or not you would like the sequences, the sequence results listed with the taxonomic name and then the sequence ID next to it. This is one of my favorite ways to do it, just because say you did have a genome or a genetic sequence, or I mean, it's really helpful when like you're using proteins and things like that that may be in various different organisms. You can kind of see the organism name, and then you can find the sequence ID, which you can refer to later. So yeah, there's plenty of ways to do this. And hopefully that shows you how to do that. Just for the sake of time, I will leave other information in other videos, but if you have any questions for me, or if you're still unsure about how to do something, please send me a message or leave a comment below this video. I definitely plan on doing more videos that cover the different types of blasts that you can perform on the website. So thank you so much for watching, and please let me know if you have any questions. I'm here to help. Thank you. Alrighty, bye-bye. Let me stop recording. Bye.